Greetings, everybody. So I have another optimization problem for you, and this one sounds a little bit different than the others. At least I think it does. But when you see this word closest, that sounds like an extreme, like closest, furthest, maximum, minimum, things like that, right? So I just made this video on finding the maximum volume that a piece of luggage could have under other conditions. So it's like that, you know. But it seems different because it's more abstract. We just have this line and it says which point on the line is closest to the origin. But let's talk about how to solve it. I want to just map it out. Sometimes I think it's easier to think about things if we have a picture, and some people are visual thinkers, so I'll include a picture just in case that's you. So I've drawn a graph, and I've drawn what the line y is 5x plus 2 looks like. And I said, well, suppose we take a sample point on that line. Okay? And suppose we take the origin. Now, the origin of the graph is where the x and the y axis cross. Okay? So it's just saying, like, where is the point on this line that's closest to the origin, or where this distance is as small as it can get. Now you can kind of imagine that, yeah, there's a point somewhere on there that's as close to the origin as possible. I think it might be like somewhere over here. It's definitely not out there, and it's definitely not over here. But, if I could just imagine like moving this point along, watching this distance, get bigger and smaller. I think it'd be smallest like somewhere over there. Okay. All right. Now, in order to do that, or for any of these problems, any of these optimization problems, if it says to minimize distance in this case, to find the closest point, I need some formula for distance. And that's not something that we've talked about in this class. So let me tell you a little bit about the distance formula. This is what we need, okay? So if you have 2 points, let's say, on a graph, point 1 has x and y coordinates x1 and y1. Point 2 has x and y coordinates x2 and y2. And this is the straight line distance between them, d. Then here's how you calculate that distance. It's the square root of, and what this means is you take this x coordinate minus that one, and then you square, plus, and what this means is you take this y coordinate minus that one, and you square it. Okay, so that's how we calculate the distance between 2 points on a graph. To give an example, here we go. Here's an example. How far apart is this point? -2 to the left, 3 up, and this other point, 1 to the right, 7 up. Okay, well, that formula I just gave you said, okay, you take this x coordinate minus that one, so that'd be 1 minus -2, and you square the result of that, and then plus this y coordinate minus that one, that'd be 7 minus 3, and you square that result. 1 minus -2 is 1 plus 2 is 3. 7 minus 3 is 4. 3 squared plus 4 squared, 9 plus 16 is 25. Square root of 25 is 5. So that's how the distance formula works in practice. So it's like, see these spaces right here? It's 5 of these spaces from here to there. Like if I could have a little ruler with spaces on it like this, that's how far that's going to be. Okay, now that's what we need in order to work on the problem over here. Okay, so let's do this. Let's say, okay, we're back over here. Let's think about it in the way that I had that other example. So every point has to have an x and y coordinate. So you see that point right there? It's got an x coordinate and a y coordinate, but here's how we're going to have to write it. The x coordinate is x because I don't know it. If I knew what that point was supposed to be, I'd know the answer, but I don't, okay? And I could say the y coordinate is y because I also don't know that, but then I wouldn't be using all the information I'm given. On this line, because it has equation y is 5x plus 2, that means the y coordinate is 5x plus 2. So I'm going to write the coordinates as x for the x coordinate, 5x plus 2 for the y coordinate. All right, so that's the coordinates of this point. What are the coordinates of that one? Well, it's the origin. It's where the x and the y axis meet. So it's going to be 0 for x, 0 for y. Now, imagine using that distance formula that I showed you over here. What you do to find the distance is the square root of, now I wrote it backwards here, but it's the same thing because when you add numbers, the order you add them doesn't matter. But you take this x coordinate minus that one, x minus 0 squared, plus this y coordinate minus that one. That'd be 5x plus 2 minus 0 squared. That's this. Okay? All right. Now, subtracting the zeros has no consequence, so that takes me down here. And then I think because when I find the minimum distance, when I want to minimize this formula, that will involve taking the derivative. It would be a little bit simpler to do that if I worked this out in here. So like, in other words, if I took 5x plus 2 squared and I multiplied that out, okay, then I get 25x squared plus 20x plus 4 plus x squared, and then I added the x squared and the 25x squared. I got 26x squared. So just working out the inside that way, I think will make the derivative part a little easier. So I do that, and also for the sake of using the rules of derivatives, I should write this square root as a power of a half. Okay, yes, so there's your formula that measures the distance on that graph. It allows me to find the closest point by minimizing it, right? And we do that by finding the derivative and setting it equal to 0. So let's look at that. Here's your derivative. The rule for that was called the chain rule. What we do is we take this power, we bring it down to the front, we subtract 1 from it, and then we multiply that by the derivative of whatever is in there. What's the derivative of 26x squared plus 20x plus 4? 52x plus 20. Now I did a little rewriting of that. I got this 2 under the bar. There you see it. And this negative exponent allows me to send this entire expression under the bar, leaving 52x plus 20 above. Solving d prime equals 0, well, I'll take that, what I just got, as the derivative. I'll set it equal to 0. And then as I got to this next step, you can think of it as, just as a quick analysis. I mean, there's a lot to write down here, but say I was going to solve x divided by 2 is 12. How would you solve that? Well, you would do like this. You'd multiply both sides by 2, because you'd cancel the 2 over here, and then multiply on the other side, you get 24. So same thing here. I'm going to multiply both sides by this denominator. 2 times 26x squared plus 20x plus 4 to the half power. It will cancel it on the left. And what's it going to give you on the right? What's 0 times that? What's 0 times anything is 0. So I get 52x plus 20. Move the 20 over, divide by 52, reduce it. I get negative 5 over 13. So what we're looking at there is the x coordinate of the point on the line closest to the origin. So that's part of it. Now, maybe that's the entire answer, depending on how they ask the question. What's it say? What is the point on the line closest to the origin? Here we're giving an ordered pair, an x and a y coordinate. So negative 5 over 13 is the x coordinate. So I have to look around and find the y coordinate. How do you think that if I know the x coordinate of the point on the line closest to the origin, how do you think I could find the y coordinate? Is there some equation in my work or that I was given that you could find the y coordinate if you knew the x coordinate? But the original equation, you know, the line that we were dealing with, it says when we started the question, you have this line y equals 5x plus 2. Well, that's what you're working with. So use that. So I take my x coordinate, which I know, I put it in there for x. and I do some calculating, and I find y. Okay. All right, so now I know the x and y. The x is negative 5 over 13. The y is 1 over 13. So there you have it. Whoops. There's the x and y coordinates. So I got that function that gives you the distance between the points. I found the point on the line closest to the origin. And then one last thing is it says find the interval of interest for the objective function. I'd like to pull in a question I just did, and where I told you the interval of interest for the objective function, it just tells you the possibilities for the variable. Like, so here it was the width of this box. And, you know, to be dramatic about it, I said, well, the width can't be 1,000 inches because then it would exceed the fact that the sum of the length, width, and height of the box can't be 144. So how could the width be 1,000 if when you add all the sides together, you can't even be more than 144? So obviously there are some limits, all right? And we came up with the limits in this question. So that would mean the same thing over here. It'd mean what are the possibilities for the x coordinate. And although, you know, it looks like the point that's closest to the origin is somewhere in kind of in the middle, I can't rule anything out, all right? I can't say that it's absolutely impossible that any point is not the closest, because I'm just looking at this picture. I mean, the picture doesn't really prove anything. It kind of motivates my thinking, but that's it. So that's why the interval of interest is negative infinity to infinity. We're just saying that you know, any x is possible. You know, I can't rule any x out as being out of the question, impossible, like I can with 1,000 inches width on the bottom here. Okay, that is most definitely impossible. I can't make that. I can't rule out anything like that on this question. So yeah, that just means any x is possible. Okay, now I think our picture is correct though. I mean, where's this point? Left 5 over 13, right up 1 over 13. That's like left a little bit and up a little bit. So when I was originally looking at this picture, I thought, which I tried to draw as accurately as I could, I thought that maybe right over here somewhere is where the point on the line is that's closest to the origin. And I think this corroborates that. You know, I would have never known it was those exact numbers just looking at the picture, but left and up, you know, seems about right. Okay, in any case, there's our solution for this one. There are lots of things that I could review about this if needed. This is true with any of the videos. If we needed to review all the algebra to work this out, the rule for the derivative, the solving, like any math video that I could ever make, I could go into way more detail. All right, I try to find the middle ground, and for some of you, I may be leaving stuff out. So if there's some reviewing that we need to do about the factoring, the algebra, the rules, whatever it is, just let me know and I'd be happy to do it.